Hi everyone, my name is Mr. Edward Ecker and today I am here to discuss about AWS Lambda, how AWS Lambda fits into an overall AWS ecosystem and something known as AWS CDK, which is Cloud Development Kit, which is similar to Terraform but not so similar that you will get bored. So let's get started. Disclaimer, things can break, they will not because I'm not going to learn anything, but yeah. Wow. That was good, right? Okay. So about me, I'm a data scientist, backend developer, AWS Cloud Architect, Neo4j professional. I have been programming since after 10th course. I recently joined AWS as a founding team member. Whenever I get time on weekends, I do mentoring for interns in FuseWise. So that's about me and almost anything in tech. Before we start, there are some things common between my session and the previous session. First is infrastructure as code, like my AWS CDK part and Terraform. Both are infrastructure as code, and there is something else. And we both are from the same college, which is Dubai College, Matunga. So, agenda is pretty small but pretty big. We will discuss about AWS Lambda. We will come to know when to use it almost every time, when not to use it very rarely. Then we will see what all AWS Lambda integrates with. There is quite a lot. This is not a full list. It's just like this, 30% or 40% list. I don't know. And then we will see some code about using AWS CDK with AWS Lambda and one of the services. And in time persists, we have a Q&A session where we can just have fun. So what is AWS Lambda? It is simple. You can run code without servers, without you going bankrupt. Best for college students. You have some college project. You only want to show once to your teammate and the second time to your teacher. After that, and after if you don't want to show it. But you don't want the EC2 machine running continuously. You can't also stop it because you are afraid what will happen if it doesn't work when I start it again. You can use AWS Lambda. Whenever you invoke it, whenever you use it, you pay. What's better about it? You don't need to even directly invoke it. You can set up triggers. So when something happens, when I turn on a switch, a light turns on. It's like event. So you can trigger it on an event. Generally, we use AWS API Gateway, which is like API Gateway, to trigger Lambda. But not so recently, AWS introduced a facility of directly invoking the Lambda function. So you can just get an HTTPS URL, which you can just read it from your curl, from your API, from anywhere, literally. Also, it supports multiple languages, so like Python, Node.js, Java, Ruby, .NET, and custom runtimes. Also, there is a limit of 56 MB for the disk space, but if you go for Docker image, you can have the space limit of up to 10 GB. So, yeah. So, when to use Lambda? Almost every time, but like especially when you have to do something related to event-driven, you have to develop serverless APIs. You want to run something on schedule, like every 5 hours, or say on 25th February at 10:33 PM, or something like that. You can use AWS Lambda. Talking about microservices, you can set up a microservice cluster, and your individual functions can be your AWS Lambda functions. Real-time stream processing, you don't know when a stream is going to come. So whenever something changes in your DynamoDB database, whenever something changes in your DynamoDB database, it is a stream called a DynamoDB streams. On that, you can invoke a Lambda function. And your imagination is the limit. Just be sure to evaluate the trade-offs. Like 99% you won't go bankrupt. I can't say anything over 1%. So when not to use Lambda, where Lambda is not a silver bullet, it has some limits. It has a maximum timeout of 15 minutes. If your code takes more than 15 minutes, sadly you can't use it. Stateful application, like REST APIs are supposed to be stateless, but we developers sometimes do stuff that requires state within the code. So if you require such state, you have to use some external database or say elastic cache, which is like cache. If you have something extremely high frequency, like फटाफट आ रहा है और एकदम फास्ट रिजल्ट चाहिए. Lambda has something called as cold start problem. AWS recently introduced something known as snap start. So what they do is that your code initializes the code and they take a snapshot of your memory. So it's like चाबी लगाया चालू हो गया, जीरो से रुक गया था. But of course that also has some limitations. So there are some cases where you need to use EC2 servers or ECS, maybe ECS for it also. Again, cost prohibitive workloads. Paper use is generally cheaper if your use is less, but if use is extremely high, then it's better to go for reserved EC2 instances. Just pay upfront for 1 year and you are good to go. So, but you generally don't find servers anymore. So get ready for the Tufani tour. I have around, I guess, 10 AWS services I lost the count, which Lambda integrates with, and we are going for each. We are going to see what that AWS service is and a simple use case. Don't worry, it's going to be fun and thrilling. So the first is API Gateway. So AWS API Gateway is the one-stop solution for putting something in front of Lambda. You can have REST API, you can have HTTP API, you can have WebSockets. Simple request response transformation is also possible. For example, you suppose you have APIs in your typical EC2 backend. You can put API gateway in front of them. But say in your typical EC2 backend, you have 100 APIs. And for some reason, you don't want to add a middleware in it. For some reason. But you want to transform some request or transform the response of your EC2 backend. How can you do that? Well, you can just put a simple Lambda function in between. So your plans will hit the API gateway, it will hit the Lambda, and then it will hit the EC2 backend, then again the Lambda, if the API, and then the API gateway, and then the client. So that's one use case. You can also have usage plans. It's like you can configure the rate request per second. Like, I don't want 5 requests per second, more than that. I don't want 10 requests concurrently. My user is a free user who does not like to pay, so I will only allow him to call my APIs 10 times a month. If you want more than that, just pay. So how you can control that? You can just do an API key to your plan and set up a usage plan and associate that plan with the API key. So API gateway will take care that your customers only get what they are paying for or not paying for. So this is simple. Say from a WebSocket message you send action chat message hello. Your client will continuously connect to API gateway. On message we have something known as route selection. So route selection is something which via which API gateway will decide which Lambda function to hit. So you can have filter basically like an if-else statement. If-else or a switch statement. So if my action is chat, hit that Lambda function, chat Lambda function. If my action is status, hit the status Lambda function. How does your Lambda function give response back to your client? Not directly. It will just use the method post to connection. It will pass the connection ID of your client and then whatever the message you want to send back to the client. And API gateway will take care of sending that. Then, as I said, function URL. You don't want to set up API gateway, no worries. Just configure function URL, you will get a dedicated HTTPS endpoint, just hit it. You want only it to be only accessible from certain endpoints, you can configure CORS, it's easy. And if optional, if you have to hit that Lambda function for whatever reason from inside your system, you can of course set up IAM. It's simple. Client invokes the Lambda via function URL and gets the response. Direct. Talking about direct invocation, you can also directly invoke the Lambda from your CLI or SDK. Some instances like say I have a Python script running on my EC2 machine and I have to offload some tasks like task A, task B, task C. I have to offload that task to multiple Lambda functions dedicated for them. Because my EC2 machine is, I don't have money and the EC2 machine is say 2 CPU, 2 GB RAM. And but those particular tasks which are very rare requires 6 CPU, 10 GB RAM, which is the Lambda script. What I can do is I can just invoke the Lambda function from my EC2 script. It will run on 6 CPU, 10 GB RAM, and once I get back the result, I will proceed. For those rare use cases, I don't need a 6 CPU, 10 GB RAM machine running 24/7, right? I can have a small machine running 24/7. And some peak workloads I can offload to Lambda. That's cost saving. It's great for testing and development and maybe in production as well for my use case. Also, there are two invocation methods. Either it can be synchronous, like hit it, wait till it completes and get back the result, or as an event, hit it and forget. If it's synchronous. It's like simple. The application invokes the Lambda function. It does the data in the synchronous manner. Schedule invocation. So event bridge is like the hub, central hub for all your events. You can configure events, you can configure event rules, fixed rate, non-expressions like every 10 years or something. Or say whenever your EC2 machine goes down, it of course sends something in CloudWatch log. It sends something, right? Something happened. You can set up event rules that will match. Okay, is this what I am looking for happen? Is this what I am looking for happen? If it matches, like the event rule matches, you trigger a Lambda function. So you can maybe say EC2 instance goes down, you have an event rule for that, it matches, it creates a Lambda, invokes a Lambda function and it sends a Slack message, hey machine down, wake up. So that can be a use case. Time-based triggers, like the example I'm going to show is like, let's have your development environment working only when you are awake. So when the developer is sleeping, no point of having the development environment up. So you can schedule like that. It's simple. Your event-based scheduler, you set up and schedule event. Whenever the event gets triggered, you invoke the Lambda function and perform some scheduled tasks. S3 event trigger. So AWS S3 is like a simple storage service that's S3 times S3. It's like a bucket. It's not a directory, but you can think of it as a directory. So it's like say folder 1 / folder 2 / folder 3. The key is like folder 1 dot folder 2 dot folder 3. It's like a key. So whenever some operation happens within your folder, like say you upload a file to that folder, you want to do something, like you upload a file, do something. That's S3 event trigger. For example, image processing, data validation, etc., etc. It's like a user uploads a file to S3 bucket, S3 event gets triggered, which invokes a Lambda function which will process some data and you put in some S3 bucket. Don't put in the same bucket with the same metadata and deficiency. It will go in and do. Step functions. So as I mentioned, Lambda does not store states. It has a timeout limit of 15 minutes. What if you want to do a bunch of stuff in an orchestrated manner, but don't want it in your EC2? When you can use step functions. So what are step functions? Step function is simple. You say this is the start Lambda function. Whatever this response is, you can evaluate it based on a bunch of rules. And then on that basis on the bunch of rules, you can decide what to put next and next. For example, me, Amos sir and the volunteers are all the Lambda functions and Nilesh is the step function. He is the orchestrator of this event. So kind of that. Of course, you can have error handling, retries, parallel execution, anything. It's like orchestration, whatever is possible. And the best thing is that it has a visual workflow design. So you can visually see what is going on. So it's simple. A process order comes, the Lambda function invokes, it either says payment success or payment failed. Then there are choices. It's simple. If the status is approved, then do this Lambda function. If status is rejected, do this Lambda function. And the appropriate Lambda function gets invoked. Kinesis data streams. So AWS Kinesis data stream is for your real-time processing. Data comes in a stream. You can do transformations and you can send it out. It's like a stream processing stuff in AWS. Your streams can be come from anywhere. As mentioned in the slide, you can come from quick stream analysis, IoT data, financial data, and almost anything. The data is pretty much simple. Your IoT devices using the AWS SDK emit certain events, like say sound. Every 1 hour it sends a sound, it goes into Kinesis data stream. Your Lambda function processes them, does some real-time analysis, and shows the result somewhere. Now, if you are, say, it is your IoT device is solar panel, you don't want it running in the night time. There is going to be no data. So either you can have a EC2 machine running only on day working hours, or you can also have Lambda if the streams are, say, infrequent. If they are frequent, you can afford an EC2, but if they are infrequent, then a Lambda is a better choice. Then Amazon data files is simpler. File host is just is intended to stream data into a destination such as S3, Redshift, or Elastic. Yeah, I guess Elastic. So it's fully managed. So where Lambda comes into picture, once you send the data into Firehouse and before you put it into S3, Lambda sits in the middle. Any transformations you want to do, you can do. So it's simple. Your data processor stream data, which data processor can be Kinesis data stream, by the way. So it streams data into data Firehouse. You can optionally use the Lambda function to transform it, or you can just directly put it into your not Elastic search. You can directly put it into the destination. Event bridge. Yeah, this is different from the schedule. So it's like for event management, kind of not pops up, kind of pops up. So your event bus, your applications emits events to your event bus, and then you can check if some rule gets invoked, like something matches, etc., etc. Where Lambda comes into the picture is that you can enrich certain events after filtering them based on JSON rules, and those enrichment, like take some event, okay, my event matches, call some API to get extra information, update the event, and pass it over. So that thing, calling an API, updating the event, your Lambda function can do. So it's simple. Application A publishes an event to an event bridge. If a rule matches, you can invoke a Lambda function and you get the result. Or you can have something as known as pipe, event pipes, where you can filter, like you can filter out unnecessary events. Optionally, you can enrich those events using a Lambda function, and then you can pass on the enriched event to a destination. Not only your custom events, but also like events from third-party SaaS providers or something like that. They can also publish your event buses. DynamoDB streams. So AWS DynamoDB is a pretty good database. You can capture changes when they, as and when they happen, and trigger the Lambda functions when those happen. You can use that for a bunch of stuff like auditing and logging. Like it's simple. Something happens, your Lambda function gets invoked. Now what that something happens, almost all AWS services. Again, say my application writes to a DynamoDB table, DynamoDB streams, invoke a Lambda function does something. For example, send a Slack notification or publish an event to SNS, etc. API gateway authorizer, as I mentioned, API gateway sits at the forefront of your all the backend APIs. Say your client sends a JWT token to to call some API. You want to validate the AWS token, right? You want to check if it's proper or not. AWS token validation is something you can do in the AWS Lambda function. So it's simple. Parents it's an API request to API gateway. The API gateway triggers the Lambda authorizer. If the token conditions are good, it will go to the backend. Now that backend it can be a Lambda backend, or it can be a HTTP backend, or it can be one of the AWS services as well, because API gateway also integrates with you AWS services, certain AWS services as well. Now this was pretty new to me. Lambda and Edge and cloud functions, cloud functions. The idea is like running code close to your users. So these two are pretty similar, but there is some slight difference between them. Cloud functions are meant for simple, lightweight processing, whereas Lambda and Edge are meant for slightly heavier processing. Because those are different, there are various ways where you can run them. For example, viewer link, like the flow is simple. I make a request from here. First, a viewer request will get triggered. Then, cloud will decide from which origin is like your backend, to send the request. That's origin. So that's the origin request. Whatever the origin response is the origin response. And then finally the viewer response from your edge location. So that edge works for all four things: viewer request response, origin request response. Whereas cloud functions only work at the edge, viewer request and response. It's simple for for yourself. It's simple for simple request transformations, personalization, etc. etc. Only two services to go. There is AWS SQS, which is like a simple use service SQS. The idea is simple, you won't use in the system. One get and one send, I don't know who. But that if your system does not help you, your architecture is awful. That's not the word you use, but so whenever a message comes into an SQS queue, you can invoke Lambda functions to process it. You need not invoke one Lambda function per message. You can also set a batch size limit. So like say, invoke my Lambda function only after 5 messages come. So your Lambda function will be executed together. Like it will be passed 5 messages at once instead of one Lambda function per message. If your Lambda function is not able to handle that and it throws an error, your message is transferred to a dedicated queue, which is where you as a developer can either manually check it, or you can implement another Lambda function. One is the standard queue. If error, go to DL queue, dedicated queue, and there are some Lambda functions for doing automated checks. And if the automated checks results, you can notify your DevOps team, like hey, we could not process a message, and these are the automated analysis of that. Use case diagram is simple. Application sends a message to SQS queue, it triggers the Lambda function, and we do the processing of the message. Coming to SNS, we can simply, it's like a pub/sub system, a real pub/sub system. You can send messages to topics, you can set up subscribers to subscribe to the topics. You can have mobile push notifications, email, like AWS SNS supports sending emails. It supports sending push notification via Google's and Apple's, I guess Google FCM and Apple's APM. Yeah. And also you can integrate other AWS services. For example, CloudWatch sends an event, you can set up subscribe, like you can have CloudWatch send it to an SNS topic. Use case diagram is simple. Our application sends some message to SNS topic. We have 2 Lambda functions subscribe to the topic. You can do things in parallel. Right? And the best thing is if someone sends a message, you are not paying for anything. Like that's the best part. let's transition to CDK. This is the first time. This will be a look on your face when you first time do Terraform or CDK, but slowly and gradually it will get better. So what is CDK? Well, AWS CDK Cloud Development Kit is a way to use a familiar programming language like simple Terraform in a familiar language only for AWS. Because in the AWS CDK you can't use that code for GCP and Azure, that's a drawback. But because it is tightly aligned to AWS, it has some better, not much granular stuff. AWS CDK uses transformation templates behind the hood source dependable. Why CDK? When infrastructure as code, you don't want to do manual changes. You don't want to do the same changes in 3 regions, they will never run. Because you are making a release on Friday. So they will never run all happens on Friday itself. You don't want to do that. You want abstractions, you don't want to go into the nitty-gritty details. If you use Python with typings or you use TypeScript, you get type safety. You can check what's going to happen before you do it. If something partially fails, you can simply do a rollback. If you want to do a rollback of a successful deployment, you simply deploy the previous version again. I mean, you don't need to remember kya tha uske pehle. You can just get revert to a previous commit, CDK deploy. Version IC. Why not CDK? Well, of course, there is a learning curve, and there can be abstraction over it. Like sometimes I face this recently that I did something wrong. I expected something, but I did something else. So that can happen. Why learning curve? Because AWS console hides many things from you to make your life easier. But when you use Terraform or AWS CDK, you have to do those things. So you suddenly realize, oh, ye bhi karna hai, oh, ye bhi karna hai, oh, ye bhi karna hai. That's kind of things. For example, say there is a use where, as in the last session, you saw the VPC module. We are using Terraform VPC module, and before that, we were mentioning all the subnet, everything by ourselves. It's kind of similar, but from a console to a code point of view. For just an example, when you set up logging, from when you deploy Lambda function, I guess you don't even have to make a tick that do logging, and it does the logging. Here you have to set up a log group, you have to configure the log group, you have to deploy the log group, you have to associate that log group with your Lambda function. All that you have to do manually, like by code, not manually. But it's actually better. Like if you take the hard way, it's like taking C before Python. You understand pointers, and then when you go to console, it will be like iron. So let's look at some demo code. Here, this is production code for the development environment. It's simple. In my team, we are 3 developers. Every weekday, we work from 9:30 a.m. to 11 p.m. Monday to Friday. And we don't want our development executions running when we are not working. Like, no point. So we set up 2 Lambda functions. They get triggered on weekdays at 9:30 a.m. and 1 at night. And what they do simple. They start the executions and they stop the executions. And also I associate a function URL. Like say I get up at 3 a.m. I'm thinking, but I can't test because the executions is down. So I can hit the executions for Lambda function URL from my mobile. It will start the executions. I can quickly go to my website test, get a relief, it's working. Invoke a different URL, it is in my bookmark. Stop the executions, go back to sleep. Else think if I have not added function URL, open that AWS console on my mobile, find that EC2, start. I will probably delete it instead of starting. So this is a diagram. Here I made this for schedule trigger and the developer invokes a function URL both invoke of Lambda function. It can either start or stop any single instance. So this is the GitHub repo which I am referring to. I am using a TypeScript, not Python. Python is my favorite language. My handler is Susmit UI, not Susmit TS. But AWS CDK is developed in TypeScript. And there are something where other languages support. So whenever something new comes in CDK, it will first come in TypeScript version. So that's why I went for TypeScript. Also, it will be simple for others to run with my GitHub repo. Let's jump to the code. So this is the very simple. I will just show how much clearly already. So let's start from the package.json, the whole and soul of every Node.js project. So this is my name IAC. What is the build? Well, build is something like the entry point of my CDK application. So whenever I say deploy, this is the file which is going to get picked up. IAC.js. I know I mentioned TypeScript. Wait. Then I have some simple skill setup. It's like build. I just build my Lambda function and build the CDK code base. Why this? So I can catch bugs early, like catch syntax errors or something early while building. Basically, compile them as runtime errors. Build Lambda. This is a simple script which I show what I do. This is a generic deploy command, and here I am deploying only my dev stack. On production, I have a similar. I have deploy /+ CDK, deploy /stack. Yeah, interviews. Then these are my development dependencies. I don't have any dependencies because this is not independent. This is on my local, so I don't need any. Let's open the Lambda functions. So I have two Lambda functions, start instance and stop instance. Each of them are in their own folders. Why? Because if I wanted to put in dependency, like say I want my start instance to have the dependency of node SSH, but I don't want my stop instance to have. If I just use start instance on TS and stop instance on TS and the package.json, any dependencies I put in package.json will get bundled with both the files. If I use folder structure like this, anything I specify in this package.json will be only bundled with start applications. Currently there is nothing, but it's a best practice to have a separate. The code is simple. I am initializing an EC2 client. I am getting the instance ID here. I need to start from my environment variable. I am calling the EC2 client and setting the start instances command. Since I want this public IP, I am waiting for the machine to run. So here I am describing its status. I am waiting this running and as a public IP address. As I am just waiting for 5 seconds and time. After that, since we are using Cloudflare DNS, and whenever you start EC2 instances, IP address changes. Currently, we don't have a load balancer. If we have a load balancer, it stays the same. But since we have a single EC2 instance, whenever its IP address changes, we have to update the DNS. So we didn't want to do it manually. So basically, what I am doing is I am just picking the Cloudflare API with my token and the event key. This is the API request if you are interested. And what it does is just changes the DNS A record with the new ID. Because in my development environment, the front-end developers local is like dev-domain.com, which points to this instance from the cloud. Similar is the stop instance. Stop instance is very tiny. It's like there is no instance stop. Because I am stopping it, I don't need to update the Cloudflare claims. Then for my stack, I have common base stack between Java and Python. It is simple. For example, I am here like create Lambda role. So there is a role and a policy. The difference between them, role is like who you are. Like who you are. You are attending this meetup. And there is policy. Policy what you can do. So basically whenever I can create a role, say I can create a role attendee. And I can give it the permissions that attend event, chat in the event, eat pizza in the event, etc. etc. I can have another role, volunteer, and then I can associate that role with anything. So that thing assumes that role and automatically gets the permissions of it. So I know that to give that permission to that Lambda. I can give the permission to the role and just say Lambda, you are this now. And we just use those policies. This is some basic policy. The interesting policy is that I am allowing my Lambda function to start my instance, I am allowing it to stop my instance, I am allowing it to describe the status of the instance, basically to get whether it's running and to get the public ID. This is a common helper code to create the Lambda function. Here I am creating a log group because I want logs. Because like these are unnecessary logs, I am setting a retention policy of periods. So this kind of cleanup script, every period the logs will disappear, get deleted. Then I am reading this my package.json file. I am checking if it has any dependencies or not. If it has dependencies, what I will do is like I will take my code, I will spin up a Docker image, I will install all the dependencies mentioned in the package.json, create a bundle and upload that to Lambda. Basically my Lambda code has all the external dependencies. The AWS dependencies already are provided by AWS. Like these dependencies are provided by AWS Lambda, Lambda. So I don't have to put that dependency. But if I have anything else, I can just bundle it. If I don't have any dependencies, I can just load my code. And I am creating a simple Lambda function. The Lambda will not just say, this is the entry point indexer handler. This is my role, a Lambda role. This is my timeout, which I am passing if not do some seconds. This is the environment, this is the log. Now why I made this bench tag? Because I want the similar for and otherwise. For cron now, of course, not stopping it, but some other things. So I have a dev stack. So basically here I am reading my .env file which has Cloudflare token and my instance ID. I am inheriting the bench tag and creating a new class known as dev stack. And here I am actually defining my Lambda functions. So this is my start dev Lambda. It will time out in 1 minute. These are the environment variables. This is the stop dev Lambda. I haven't specified any timeout, so we have a default timeout of 30 seconds. Here I am associating it with a function URL. All time is like no one or like no restriction anyone can call it. Allow method is like get allow agents from anywhere methods or anything. Adding a function URL. So if I don't do this, I won't get a function URL. And the scheduling part, this is simple, it's all things. At 5:30 PM stopping. This is 5:30 PM UTC. So that's something you need to take care when you define the schedules. UTC to IST. So 5:30 PM UTC is like 11 PM IST and 4 AM in the morning is like 9:30 AM IST. So, and this is like a helper function. At the main and the hour helper function set up a rule. So I am setting up a rule, schedule. This is a cron. So on Monday to Friday at 9:30 AM invoke this. Like the target is the Lambda function. This is the function that is passed. At 5:30 PM UTC 11 PM IST invoke this. And it just works. this is a simple script to like when I do npm run build to just build all the dependencies for each Lambda function. So in the SLC folder where I have mentioned all my Lambda functions in Lambda SLC, it finds all the folders, gets the package listen and does npm. So yeah, that's about it, I guess. So when it comes to AWS CDK, as I mentioned earlier, when you go from console to CDK, first it will be like, what is happening? Should I go ahead or not? Should I just stick to console and do same thing 3 times? It might actually save time. But sooner or later it will be like, okay, it is good to use Terraform or CDK instead of manual stuff. Like I have worked with companies who are managing 2 environments. Many things manual, no ISC. They did not know even the word ISC. And when there was a KT session, they told me some AWS services. But just to check, I went to their building page to check if they are anything. But that's the page where you can come to know which are AWS services. And I saw something. I don't remember what it was, but yeah, I saw something and I asked their DevOps team, what is this used for? Oh yeah, baby chal raha hai. It was something they started 5 months back just for testing purpose for a 5-minute task and they forgot about it. So if it was in code, every day they would just see their code. But yeah, so I mean, it's also one more thing beneficial is that if you set up using console, you will be asked to write documentation. None of us want to do that. If you use ISC, you still might be asked to, but at least you can just give your ISC code to GenAI and say, hey, get a documentation. You can't give your console to GenAI for documentation. So yeah, so conclusion, Lambda is powerful. Use it in your college projects, use it to save money, use it in your organization. Use CDK Terraform, it simplifies deployment a lot. Don't get too overwhelmed, start small. And yeah, you guys can this QR code will redirect to my portfolio website where you can have my GitHub reports, my Medium articles, all my slide decks including this talk, and my social handles at the bottom. And if you want to just find me, just Google Spotify, you will probably find me. Till now, there is no one else. So, yeah.